The digital transition. The Digital Transition, a podcast series created to assist those tasked with implementing digital strategies, where we will share our knowledge and experiences to support you in your transition.
Welcome to The Digital Transition. I'm your host, Nathan Hildebrandt, and today I'm talking with Clifton Harness from TestFit about the power of parametric design and how it can assist in the feasibility and design phases of project delivery. But before I talk to Clifton, I need to talk to you about our exclusive podcast sponsor, NBS. NBS Chorus is revolutionizing construction specification with cloud-based collaboration. Integrate seamlessly with your building model, allowing you to increase productivity and reduce risk. NBS Chorus allows you to specify your project in Uniclass 2015, which is recommended by the Queensland Government BIM Data and Information Guidelines, as well as the Victorian Digital Asset Strategy Guidelines, and mandated by Transport for New South Wales. To learn more about NBS, head to their website www.thembs.com.au. All right, thanks very much for taking the time to talk to us today, Clifton.
It's a pleasure, man.
Now, firstly, we've caught up a couple of times virtually, and I look forward to the point in time when international borders and travel enable us to catch up and face-to-face and have a beer together. But for the listeners that aren't aware of who you are in your journey, can you tell us a little bit about yourself?
Sure. I am a co-founder of a AEC tech startup called TestFit. We are based in Dallas, Texas. And we have been in business for about 4 years. And, a significant amount of the multifamily units planned in the United States go through our software ecosystem. So I'm not going to give a percentage because it's a little bit terrifying, but I can tell you it's a significant amount.
That's something small to say. But before you started in software, where's your education?
Sure. So I went to the University of Texas at Austin, got a Bachelor of Architecture, which in the U.S. is a 5-year professional degree. Lots of studio. I mean, I was really focused on becoming a licensed architect. I felt like that's what, where I wanted to go. And went into internships, started to kind of see a really big disconnect between people, product, and process in architecture. So like the people were always incredible. Like I never worked with a single person that I didn't like working with in architecture.
That's a positive.
The products were great. Like the buildings that we designed were excellent. Things to be proud of, but there was a disconnect in process. So, for example, like I would institute, write a simple Lisp routine, to solve like a red line across 300 sheets, like execute that. And then I would be told that I need to go home because they didn't have any more work for me that day, So there was I was de-incentivized from innovating process because it was terrifying, oh, this guy uses a Lisp routine. That's insane. Why would you ever touch CAD files with software? So that perspective was, I don't know, a perspective. I loved architecture. I was willing to go into it. And I really wanted to understand private development in the US because I felt like I would, if I were to be an architect, I would want to do buildings that would affect a lot of people. And in my mind was that was apartments. It was housing. It was, the commodity stuff. And so I worked for a real estate development shop in Dallas that did design. They were vertically integrated design, build, develop company. And that was an absolutely absurd job to get right out of school. Nobody gets that job, being a site planner, for this company. So I was in my early 20s, site planning multifamily buildings, and started to understand that the process problem was also true in real estate development, and also in the construction company that we were working with. And, it's like you just sort of look around and you're like, wow, we've been focused on the assets, but not in the process to create the assets. Like that has not been a part of the discussion whatsoever. And so while I was there, I instituted a lot of automation tools. When I left, they had to replace me with a team of, I think, 7 people.
One person so to 7. That's a compliment, isn't it?
Well, yeah, gave me no budget and told me to do everything. Right. So it was a welcoming experience to me because it gave me the vocabulary that I needed in order to disrupt the entire process. And so where we started was with the deal, focusing on a deal. And this is different from a project. So, oftentimes you have a project, there's a contract signed, people know like where money's coming from. In a deal, everybody's doing it at cost. Like you're just trying to figure out site plan, pro forma, construction cost. You're trying to get everybody on board for those 3 things. And, that's really where we've been focused on solving the problem at TestFit is in that realm of the process. So it manifests itself in a building configurator, which is, what most people know us for is the gifts of buildings that are, basically living, breathing documents. But the reason why it's a configurator is that everybody needs to be able to change parameters in that project stack, not just the architect. So there might be a unit mix that's really important to developer that maybe the architect doesn't really need to have their hand on. And democratizing the input of that information to more kinds of people has been quite disruptive to the process in a good way. Like we're getting more deals done more quickly through TestFit than we were before. And more importantly, the worst deals that we're going to architects to get, fleshed out into SDs don't even make it to SDs. They just get killed.
That's a positive.
So you're increasing the productivity of the whole process just by setting the deal up for success.
Now, you've just touched on the concept of essentially a generator that TestFit is, but TestFit's reasonably new, and it's only reasonably new, I guess, in the sense of for software vendors out there. So you're still in that kind of, it might be rude to say startup phase. You're probably in the next phase. You're probably past that first, the bad, challenging part where everyone's struggling. The fact that you're saying that there's a rather substantial percentage of family units or multi-unit apartments, as we call them here in Australia, that has been developed through your platform. For the listeners that possibly may have missed that kind of, or don't understand half the terminology behind what you've said before, can you just explain about TestFit? In a kind of a broad manner, and the history that you have as a product and a business, because it's only 4 years old, isn't it? I think we've talked about before. Just talk briefly about, I guess, the history of TestFit and what it does. And I guess it was born from your realization. And I think the really interesting thing that I take from all of this and all of the exciting people I get to talk to on the podcast is that a lot of the people that are developing some really incredible software are people that are frustrated with what they're doing in their day-to-day jobs, drop architecture, drop engineering, and jump in and do something new and exciting. So let's hear, we've heard about it here in Brisbane here in Australia before, but for people that are listening that haven't seen you present before on your tools, what is TestFit?
Yeah, sure. So as I was alluding to earlier, it's a configurator. And when we started, the first initial release that we had in 2017 was a tool that you could draw a property line and it would generate a rectangular parking garage with multifamily units sort of all around it, right? And this is a wrap typology. So in the US, we have, 30 probably multifamily typologies, and 8% of multifamily buildings in the US are these wrap typology. And wraps are super annoying to draw because you might have 90 different stacks of units, and they're super annoying to count all the units to then confirm that you have the right number of units and you have the right unit count compared to your parking ratio and your parking count. So that was the initial configurator, was like, how can we just generate this thing so we're on a target, like we're on any kind of target. And that quickly grew into the podium configurator that's got, more of a structure to it in the ground floors. And then there's, a tower on top, and then the lower density configurators like Urban, which is like a surface park tool with much higher density building. Really in the US, it's all about like, how are we mitigating or how are we handling parking versus what is the layout of the building? And so there's low density housing, which might look like single family homes or duplexes or townhomes. The duplex configurator is the same as the townhouse configurator, except you just don't have a gap between the buildings, right? Like it's much more dense.
Yep.
And so we codify all these concepts of like what a housing unit is and these different orientations, codify them into software, build the software around it. And it's a generic solution to a, point problem. And a lot of people have this point problem of needing to understand how many, units you can fit on a piece of land.
And that then generates the value of what they might be willing to pay the landowner for that land.
Yep. Yeah. They're always trying to back into, okay, how valuable is this land? Because you can only get a certain amount of rents, and hard costs are relatively the same compared to, this site and across the street site. So what is the land seller, willing, how is the land seller willing to move? And that's, not typically in the US would an architect be involved in that discussion, but their their site plans are used to value land. So their site plans are incredibly useful to the development process.
So you'd be probably finding a few real estate agents possibly, or entrepreneurial people that want to try and make deals and partner, find land for a developer, or developers might even be utilizing your tool.
Yeah, so we have our three big customer groups are developers, architects, and general contractors.
Yeah.
It's about neck and neck with development and architects, and then a minority is the general contractors.
Yeah, but the contractors are very rarely the ones that are bringing a property development to market. Like, it's a unique scenario, unlike your, all the way to market design, real estate, and build in one hit. There's not a lot of. There are a few of them out there, but there's not. It's not a general business model.
There is a tranche of general contractors that are incredibly active in pre-con. And oftentimes it's not just like a GC, it's like they've hired architects to help them manage the pre-con process, because they can save money in the long haul just by being more clear about what is in a building versus what is not in a building from the get-go. So I'm pretty excited about seeing more sort of pre-con control in the deal phase. Like, I think it'll lead to more informed decisions about hard costs, which right now industry-wide hard costs is incredibly opaque. Like nobody knows what anything costs. Like even if you ask a pre-con guy that just got done pricing something, hey, like how much does that same thing that you just got priced cost now? And they would have no idea, right?
Yeah, well, I think the challenge is here and here in Australia, and I don't know what it was like in the US through COVID, but here in Australia, construction prices have gone through the roof. Real estate has gone through the roof in terms of costs and prices. The escalation has been incredible. So I can understand how that it makes it hard, because each of the subcontractors are essentially the ones that control the prices for builders. It's not the builders themselves. But that could be a whole podcast in itself, and I probably should get a QS. I should get a QS involved.
How to have the technology revolution in subcontracting, like, that's going to be even bigger to the process than BIM was, and there's not a whole lot of movement in that direction.
Well, even the manufacturers and suppliers, it's almost it's a sad thing, but it's almost possibly like the supply and demand with the share market, right? So. Today, concrete's worth this because we've got our plant sitting doing not as much as we normally do. So we'll sell concrete cheaper here today than we will in a week's time because we've got too many people ordering it that same day. That's a scary thought, isn't it? But I don't don't get any ideas and try and change your product.
the market is becoming more clear, right? Like 30 years ago, if you're going to price out a deal, right? Like it's not going to change a whole lot. Like some guy doing the bid, like there wasn't technology that's firing off, APIs to request pricing from X, Y, or Z. Like it's much faster now in parts of the stack. And I think what we're after in the long haul is to be able to support like a real-time pricing environment where like the subs trust what's in the model. The developers, everybody trusts what's in that single source of truth.
Yes.
And that single source of truth is not going to be a Revit BIM model. Like it's just not. So we need to create a system that actually works for the whole stack.
Now, before we get too distracted, I've got to pull us back into line. And one of the things that I try to do with the podcast is to try and assist the people that are listening to it to understand different terminology. And the reason for that is because there's a lot of good marketers out there that spin buzzwords, I guess you could say, make people think that things are doing things that they're not, and then we end up with semi-informed people coming out saying, "I'd like to have this, please." Now, I'd like to dig into a bit more detail as we go through our conversation, but before we go down that path, it'd be good to understand or get an explanation from you about what your belief is in the terminology and the differences between, say, parametric design and computational design.
Ooh, all right. So I am from Texas. I'm a very simple person. I mean, I see a thing and it means a certain thing to me. So, I don't think you're gonna get like the Webster's dictionary, definition.
We don't need that,
but
it's more about what does industry see it as?
Yeah. So, all right. So parametric design is when the thing being designed is driven not by like your hands. It's driven by a number or a formula or something that has taken some kind of intelligence from the user and embedded it into that tool. And so what that could mean is, for like, I had a boss that walked up to me and basically told me the recipe for how we're going to do windows, on this building. And he explained that we need 2 units of glass for every bedroom and 3 units of glass for every living room. So essentially what he described is a parametric constraint for how units of glass are going to be allocated, across this building. Computational design is actually figuring out how to take those units of glass and mathematically place them across the building, from a 10,000 foot view. Like, so one is the idea that things should be constrained, and the other is the idea of actually implementing those constraints. That might be how I break it down. There's a lot of fluff. There's generative design is another one. Like this fallacy that, you can plug in all of the constraints of a building and like you click a button and then it just like the machine knows how to find the best solution. Like, we're already doing generative design right now with everybody. Like the GC has an idea of what the cost should be and what materials you're going to use. And so you have goals and you have constraints and you're doing it in real time, like with the people around you. Like it would make more sense to me to do like generative design, like from the like whole OAC, perspective, as opposed to we just want to make like the biggest building that can fit inside this zoning envelope. Cause that's not always the best building. Like sometimes, nearly always, that isn't the best building. Like that's something that takes up a lot of space, but it wasn't very easy to build because the envelope is super complicated and, X, Y, or Z. So That's generative design. And then I use the term configurator, but basically like we call ourselves a configurator because we don't want to be, tossed in with everything that's called generative design, because we're not. Like, we solve a site plan given the user's constraints, and we give them one, and we let them optimize, to what the right solution is for everybody. It's a fallacy, I think, to hand over the building design process to a machine. Like, you just can't. We have the most constraints in a configurator on this planet right now. TestFit does, for one building typology, high density multi in US. We have the most constraints, and you don't want more constraints. Let me tell you, you don't want more. You want to let the architect make good decisions with the constraints we have, and then let them do co-creation, work with the machine to make it a better solution.
Now, one of the things I want to touch on is generative design, because it's my, over the years at many a BIM conference, and you probably would be experiencing the same in the US, these lovely marketing people put up on table and say, look, here's 1,000 options for you to check, and this is what this can generate. Here's all of these options that fit these parameters, and what
dead on arrival, man. You're telling the whole building design community that loves, guess what, designing buildings, that you're not going to design buildings anymore.
Yeah, I know. That's why we all got into the profession, to not design, right?
What's much more compelling is co-creation, which is like, we're going to let this machine do the boring shit, like counting stalls and solving the unit mix and, all the things like the life safety stuff. We're going to let it do that. And I'm going to focus on massing. I'm going to focus on the narrative for like what this site is and what it needs to do. And that's what we've been successful doing is co-creation.
Yeah. Now, for people that aren't aware, I guess, of what we were trying to talk about there, was generative design typically will push out or output, maybe 100 options for a designer to choose upon based upon the set of constraints that they've applied to it. And the sad thing about it is that it takes the architect or the designer, a very, very long period of time to then sit there and analyze against each one of those options that has been outputted to determine whether or not it's of any value. And there's some really good articles, I think, from Dr. Daniel Davis around that in regards to how generative design is dead or doomed to fail. And I think there's some really good concepts about that, and it's powerful for people to realize that, some of these ideas that come out, have a lifespan. BIM won't have a lifespan. BIM will continue on for those that are naysayers, but generative design, I think, the logic that is BIM is never going to go away. Like, you've spent 20 years, billions of dollars investing into like, here's what a wall is and here's what a door is, and like, here's how these things relate to each other. That's super valuable information and a super valuable tool and ecosystem to have. Where I think the future of BIM is like me being able to control BIM operations from TestFit, so that like I end up with a good, clean BIM model that others can reference. But I don't want to have a BIM model that's created by like an architect manually drawing in every single wall. Yeah. Like, the algorithms can do that pretty effectively. And they can make sure that, the orientation of every wall is correct. And they can make sure that like it's constrained in the right way. And, I think we get to model-based delivery because we let algorithms handle a lot of the detail. And I know that's a crazy thought that like an algorithm is going to be drawing all the walls and stuff in the future, but like, I think that's what needs to happen in order for model-based delivery to be, to be the thing. And it means that we're focusing on good things, right? The architects get to focus on more value-adding propositions rather than doing the mundane.
Yeah. Like job that I had modeling as an intern was, it was a 2 million square foot hospital, and the job was to place these plastic wall guards on every single corner, like every single outside corner of a wall that occurred. And so you're like, oh, wow, this is going to be a long task. And I did it. I manually did the whole thing. And now when I look back on, I'm sure I missed a lot of conditions. Like, I'm sure I did. because it's just there's 2 million feet and there's 17 floors and you're one intern, and every time I place a wall guard, the whole model has to like regenerate and I gotta wait, and it wasn't like super fast, but then again, this is like 2014 auto Revit, so it's maybe faster now.
Maybe that's the wrong platform. See, I'm an ArchiCAD user, so. But yeah, well, let's not start that well.
Like we gotta get more ArchiCAD users in the US. I think that would be helpful.
Oh, it's neither here nor there. But what you're talking about is performing tasks that essentially are prone to mistake, because as a human, we're doing something. We have a process essentially a condition that we need to meet, and if there's something that can automate that process, then it'd be better to do it. Because the sad thing will be is you'll place those corner guards in, and inevitably someone would then change the design on you, and when they're changing the design, because their role wasn't to place those corner guards, they'd forget,
right,
and wouldn't replace them.
The proper solution in my mind is like, okay, we need wall guards. So that means that, hey, model, anytime that there's an outside unguarded corner, place a wall guard there. And like, let the designers move things around all they want. And then they're done moving things around. Then the model just updates.
Yes.
Like it just like, you don't even have to worry about it. It's just there.
Yes.
Like that's the kind of innovation that we need out of our software in order to take architecture to the next level, is like, give us smart modeling tools that, follow a logical, path. And, like we're going to keep doing that at TestFit. Everything's going to be parametric. It's going to be generate, edit, right? That's the model, is generate, edit, export, as opposed to edit, export. That's the innovation, is we're just starting not from nothing.
So normally my thought process is that at this point in time, the concept behind TestFit or any other tools regarding, parametric design concept, all that sort of stuff, apart from when you start getting into other scripting tools like, Grasshopper and Rhino, is that the substantial amount of value at this point in time is obviously in the feasibility phase. And are you seeing and the way in which your tool works is it takes your site, you plug in the constraints based upon certain local regulations, and then start tracing and stretching and identifying how things would fit. For those people that aren't involved on that side of the fence, they're the client. They're the one that is engaging a professional to identify this sort of thing. So going back to your real estate developer days, how long would it take you to essentially manually work through a process to see how much you could fit on a site versus, I don't want to kind of, the half an hour to 1 hour process you can use your tool in, that's kind of where it's gotten to.
Yeah. So like there's a couple things to consider. To generate one manually is like an 8-hour exercise, and it depends on what that deliverable needs to look like. If I need to have 3D, if I need to have, more expanded tabulations that include unit mix, if I need to have like my parking garage drawn with, the right, I have a ramp and my ramp is at a 6% slope. Like it depends on what I'm showing. Right.
It could be a week.
Right. Like if my goal is to get a set ready to go so that it can be priced, which should be like what every architect's goal is. Like I need the minimum viable pricing set in concept. That's an 8-hour exercise really to do it well. You unfortunately have a situation in AEC where the guys doing the site planning are also the guys, running everything. So they don't have time to put their best foot forward on every single site plan. And that's another thing that like real estate, they're going to start demanding more iterations, especially when pricing is so weird. So you have to have a system to respond quickly. So on the first one, TestFit's about 100 times faster, getting everything done. But if you need a second iteration, and I'd wager that nearly every single one does, you're looking at, 1,000 times faster. Yeah. So it really just depends on the problem. Is it a building that TestFit's really good at generating? Then it's a slam dunk. If it's something that we're not that great at doing, and you have to like use more of the manual tools to get it in a shape that, is what you want to send to an owner, then you spend more time on it.
So that makes it a clear winner in terms of people being able to embrace that, because then it's a quicker process. And one of the things I guess that you could have touched on, which we didn't, it was kind of fixated on just time in terms of that one thing, is, the challenges sometimes that someone could actually miss a whole pile of cars that they possibly should have remembered to do, because we're sitting there and remembering, this is what we have to have on this project, rather than software reminding us.
Yeah, the number of times where like you would have a site plan go out and the tabulations being completely off, I would say maybe 10% of site plans are inaccurate, if not more. And like, I don't know, with TestFit, we use the same exact algorithm to tabulate everything every single time. So, it might not be like the perfect tabulation, but I can tell you that, any scheme in TestFit compared to any other scheme in TestFit is an apples to apples comparison.
Yeah.
Like they are derived of the same math.
Yeah. But I guess that then comes to my next question, and I have to, and in Australia, I'd normally use some different terminology, but I'm trying to keep my podcast as a PG rating, so we don't have expletives in here. But the challenge, the normal statement is, if you put crap in, you get crap out, right? So that's where I think it's kind of an important thing to understand. There is that as long as the information and the rules are right, then the outputs are going to be good. And the challenge with most people is, say, for example, we take other tools where you got to kind of start from scratch. And like even generative design, you have to start from scratch in the sense of telling it all the rules. If you don't actually...
Right.
The challenge for most people is you got to remember to actually incorporate all of the rules. If you don't incorporate all of the rules and you're one or two rules short from what's really required, then the output's actually wrong.
Isn't that great?
But I guess that's the challenge.
It's like in generative design, like, if I could only make the perfect constraint environment, that I could get the perfect building out of it. It's like, we spend a lot of time thinking about like, what is a good enough building to start with? And that's like our barrier for success. If this site plan if this new industrial thing generates a site plan that is like good enough for someone to get an idea, that's great. It's better than what we had before, which was I have to pick up a phone, I have to call an architect, wait for him to have time to, draw my site plan for free. Okay. He draws it. Okay, now it's back. It's 2 weeks later, and the broker already sold the land to somebody else.
Yes.
So architecture, like you can make yourself invaluable by having an instantaneous feedback loop with that developer, or they're just going to, start adopting this technology and
doing it themselves.
Yeah, doing it themselves. Yeah.
I'm looking forward to, and I guess it's probably premature for an Australian audience, I guess, at this stage with where you're at. But I guess the key thing being is that the takeaway is that people need to start to think about and understand the opportunities that, or sit down and assess the processes that you're currently doing day to day in your job, and think that, maybe there might be options for automation to make life a lot easier for yourself. Now, I think the conversation will be really exciting here in Australia with the product and the tool that you have in 2 years' time, as if the trajectory occurs in the way that you hope it does, and I'm looking forward to that happening and seeing how that pans out.
I'm confident that the trajectory is headed in a direction that will please a lot of people. And I'm very humbled to be able to say that.
Yeah.
Like you're talking to me after 4 years of literally like, we before this show, we were kind of talking about, what it's like to go from 0 to 1. And it's like, I'm like a rabid dog, just like finally get from 0 to 1. And then, then now I'm like, oh my gosh, like, I don't know what to do with myself. Right. Like there's a moment of pause, and there's a moment of dreaming, and a moment of figuring out what the future is. And, the last time I remember pausing was like 4 years ago, so we're headed in the right direction.
No. And the one question I guess that's really important to kind of, before we close out our chat today, and this is the one thing that I love when it comes to talking about BIM and automation, and I've got my views on this, but it'd be good for the audience to hear what your thoughts are on this. And, being in the business that you're in and thinking into the future, and I love talking to people that think far into the future about what opportunities actually lie out there. But where do you see the future for parametric computational design, generators? And my best component of that is, will it spell the end for architects?
No, it won't.
Yeah, I know.
It's just that I hate that question, right? Like, it's not going to be the end for architects. Like there's going to be, like, as a CEO, the buck stops with you, it's like, okay, architect, the buck of the built environment is still going to stop with you. Like, you're still going to be the one taking the professional risk every single time a new building is coming up. So I wrote a blog post on LinkedIn called Architecture Firm Brain Drain. And it was like 2018. I was a young man when I wrote it, right? Like, it's been 3 years. It was a while back. But in it, I said something along the lines of, like, in the future, you will see, like a structural engineer's algorithm, working with an architect's algorithm to solve a problem together. And we were able to last year build a API with Thornton Tomasetti that basically, like, queries them for structural column sizing. So we send them an analytical model, and they send us column sizing back. So that's an example of a software company working with a soft skills professional company on incredible, workflow. I don't see the future of architecture any differently. There will be firms that get on the boat and build their own configurators and their own generators. And they will brand those things. And, when you're working in TestFit or developers in TestFit, they can choose to use ABC Architect's generator or the generic TestFit generator. And there'll be ways to monetize, in our system, in the long haul. Like, I'm saying, like, 5 years down the road, this isn't like next week. This is a long way off, is getting the individual firms to start thinking about, what would it be to actually embed our expertise into an algorithm and see it show up. Another example would be, like, TestFit generates a lot of apartment buildings, but we don't do any unit plans. There are a slew of computational designers out there that generate unit plans. It would be very easy for us to connect with those people via, like, an API to demonstrate, like, what is the actual power of, a configurator with nested configurators inside it. And so really what we're doing is, like, we're just providing the initial structure for, like, what this future ecosystem looks like and works and how it works, to be a model for how other people can come in and plug in their stuff. But you have to have a business problem that you're trying to solve. Like, I can't stress that enough. We're not just simple, like, computational designers that do something because it's possible to do something. We do it because we are creating value for very specific teams down the road.
That's exactly right. And I think that's the most important part. And we have those conversations with a multitude of people about, there has to be a business case behind every action you do and every problem you're trying to solve. Don't try and solve the problem that doesn't exist. And, it's good to see that we're on the same page there. We realise that, and architects need to realise, I think, that they just need to adapt and find ways in which they can generate greater value rather than focusing on placing corner guards, for example.
Yeah. Well, architects think of themselves sometimes as an expense to the project. And I can't stress how much, like, that's a wrong way to look at yourself, and to, like, you are a value and an asset to any project that you touch. Like, you're not a cost. So, maybe having an intern place wall guards is kind of a cost. Like you have to do it, but the decision making and the high level of creativity, that an architect brings to the process helps to build the vision and tell the story. It's not just about the building. Like there is a whole lot more to the process that architects can do if they would just be willing to dive in and be a part of it.
Yeah, that's exactly right. But Clifton, mate, thank you very much for your time today. And I have one final question for you, and it's one that I ask every single one of my guests, mate. What does BIM mean to you? And I'm looking forward to this one.
What does BIM mean to me? It is a logic ecosystem that I can query to do highly detailed drawings. I don't think of BIM as a authoring tool. I don't think of BIM as a great technology even. It is simply a logical system that enables machines to communicate what buildings are.
I love it. I love how I can tell that you're the founder of TestFit now based upon that response. It's all about the computers and how they communicate and talk to one another. I love it. But thanks.
The future of BIM is an API, man. It's nobody wants to work in a BIM model. It's too heavy. I'd rather just see a diagram of all this stuff. CAD is excellent because it's a complete abstraction of what the thing is, and you can get away with communicating a lot with a little bit of effort, right? BIM, it's like I got to communicate a lot with a lot of effort. So, I think of it as more valuable if I can generate a BIM model, so that other people can do queries on it, as opposed to I want to author this thing manually, because that's insane.
It certainly is. But mate, thank you very much once again for your time. For more information on Clifton and TestFit, please head over to the podcast section on the Skewed website for further reading. I look forward to sharing our next podcast with you in a fortnight's time. Until then, good luck with your digital transition.
Digital transition.